And we're back. And what were we doing? We're heading into evaluating and expressing in sigma notation. So kind of doing the opposite of what we were doing before. Before we got given that sigma stuff and we're working out, and this time we're going the other way around. Okay, so we're given an arithmetic progression, and there are a whole lot of terms. First term, second term, third term, nth term. And do you have any ideas of how to solve this at the moment? I can hear the cogs going along there, right? So our first term's 12. A equals 12. Feels like there it is, that information's there, let's write it down and use it. It's an arithmetic progression, so if we had D, that would be great. Well, D is -8. Cool, looking good so far. How could we use this bit of information to help us, maybe with like creating a general formula? Okay, so maybe we create a general formula, right? So we got Tn equals A plus n minus 1 D. Okay, so Tn equals A plus n minus 1 -8. Remember, always just pop this in brackets. Has been picked up a few times that if we put something like this in our calculator and we didn't have that one in the brackets, and you had something like 2 minus 1, and then you had -8, just be careful because that means subtracting 8, whereas actually you wanted an -8 so that we multiply. Okay, so let's multiply this -8 in. Tn equals 12 plus, but that becomes a minus because -8n plus 8, cool, equals 12 plus 8, hopefully gives us 20, -8n, doesn't matter which way around you write that, but there's our formula. Tn equals pause. Good to have those breathers, right? Okay, so we've got our general formula now for this arithmetic progression, and now we can use that to put it into our sigma notation. So let me provide the kind of framework here to go, well, we're going to have sigma, and we're going to go from n equals something to something. So these are the bits that we're going to have to fill in of something or other there. Let's start with what goes in the brackets. What do you think is going to go in over here? Well, we've kind of got a nice formula. Why don't we just put that in? -8n plus 20. Where should n start then? Well, n's going to start at 1, because if we substitute 1 in, we should, with a bit of luck, get our first term up there, right? Okay, now the last part we need to figure out is how many terms we've got, because then we can work out that last bit. So we've got the value of the last term. We've done a few of these over the course of a few lessons. How are we going to determine what number term this last term is? We're going to substitute it into this formula. So I'm going to write it here. Tn equals -8n plus 20. We know the value of the last term is -276. We don't know what n is, so we're going to leave it as n. Formula, solve, go for it. Cool, so you solved it. I don't know, maybe you put something in there or not. I want to solve it here instead of just running away to that calculator this time and go -296 equals -8n, divide by -8 on each side, right? -8, -8. Then we've got n equals, you know what, might as well just pop this in the calculator, and we go, well, negative divided by negative is a positive, so, and I'm happily going through this quickly because I know you know how to solve equations. Problems, shouldn't have a fraction. That looks a bit better, right? N equals 37. Cool, so n equals 37, so this must go from 1 to 37 because they're 37 terms, and there's our formula. Not too bad, is it? Probably worthwhile doing another example. Geometric progression, 140, 16, plus, plus, plus. Ideas to at least get us going on this one. Right, and can ask that question because the question came up, you can write it down and get into the question. So that was kind of the pause and breather, right? So it's a geometric progression. So we know that Tn equals ARn minus 1. We know that A equals 100, right? R equals, what are we multiplying by each time? Well, it doesn't seem obvious. So therefore, I'm going to go 40 over 100, second term over first term. Could have gone 16 over 40 equals 4 over 10 equals 2 over 5. You know, just punch in the calculator and it will simplify it for you. Pause. Okay. So Tn equals A R to the n minus 1. What do you think it means that it says plus dot dot dot? It means it's carrying on forever and ever and ever. So this actually should make our life a whole lot easier. Because sigma goes n equals 1 up to what? Well, it keeps going. So up to infinity. What are we going to... In fact, I don't know if we need brackets there. What are we going to put in this part over here? Well, we're just going to put our Tn formula. So we've got 100... 2/5 to the n minus 1. Can be nice to put kind of that whole thing in brackets, but it's not a biggie. So we've got the sum from n equals 1 up to infinity of this matches that. Cool. Not too bad. I reckon it's time for another example, right? And I think I had 4 examples down here. These are the ones in the textbook. So you can look at their way of solving it too. Okay, for this one, we're given a geometric progression. We're given the first, second, third, and last term. Looks similar to the first question, just a geometric this time. So what do you think? What's your strategy going to be for this? Well, again, we're kind of getting used to these types of things. I hope of, well, we know Tn equals ARn minus 1. We know that A equals 5. We can see our ratio in this case is minus 2. That's what we're multiplying. N minus 1. There's our thing. We need to work out what n is. We're given our last term. So we substitute n equals 5 minus 2 n minus 1. So it goes. We solve that. We get a value for n. And what value do you get for n? So you did divide it by 5 on both sides, right? You got 1024. So 2 to the power of what gives you 1024? It was 10. So n minus 1 is 10. So n should surely have been 11. And it was an even power. So therefore negative became a positive. Okay, so that was n. So therefore once we've got that, we've got everything we need. N equals 1 up to 11 of 5 minus 2 n minus 1. Okay, feeling okay? And does it feel like we've done this type of question now numerous times? You're given the last term, you need to work out what n is. I feel it does. So our last question, and this is, I think, in some ways an easy one if you can recognize it, because, you know, this isn't a plod through the motions. It's not an AP or GP, some sort of other question. You can go straight to sigma n equals summing up to something of something else. So let's run through it. What is the starting point? N equals what? Well, I'm going to go for 1. What does it got? In fact, not what it does it go up to. Let's do this part here. What are we summing? What goes over here? Well, it looks like n squared. And they look like square numbers. So therefore, last piece of the puzzle, n goes from 1 up to what? Well, it goes up to 7 because 7 squared gives us our 49. Bonus little tip, not tip, bonus point here. Could you have done this? N equals 2 up to 8 of n minus 1 squared. Is that the same? I mean, it looks the same, right? Because 2 minus 1 is 1 squared. And if we went up to 8 minus 1 squared, well, that's 7 squared. So there's no reason that it couldn't have been this one above my head over here, but that other one kind of fits in more neatly, I think. Whole lot of questions for you to do. 1, 2, 3, 4, 5. Enjoy them. Pop back into the meet. Say hi, say bye. Enjoy the day.